During the revision of this paper, this was quiz 1A. Quiz 1A. Instructions are very easy. Answer all 3 questions. Write your computer number and tutorial group on your answer script. No calculators in this quiz, so no calculators. And question 1A, if A is equal to a set 1, 3, 5, 7, 9, B 2, 3, 4, 6, 8, 10, C 3, 4, 5, 6, 7, and X the universal set of whole numbers less than or equal to 10. So the universal set is a set of whole numbers, and whole numbers, we know they count from 0 all the way up to 10, as we are told less or equal to 10. So first thing you do is to list X. So we can list X, so we're saying then X is equal to the set 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then A, B, C are already listed. Now I want to do B minus C. So what is B minus C? B minus C is the set of all the elements of B that are not in C. The elements of B which do not belong to C. So if you look at the set B, it has 2 and there's no 2 in B. So 2 belongs to B minus C. Okay? 3, there's 3 in B, there's 3 in C. So 3 does not belong to B minus C. 4 is in B, it's in C. So 4 does not belong to B minus C. 6 is in B and it's in C. So 6 does not belong to B minus C. But 8 is in B and not in C. So 8 belongs to B minus C. 10 belongs to B minus C. Now look, 5 is in C but not in B. We haven't even talked about it, because we want to find the elements of B that do not belong to C. That is B minus C. Now we intersect A intersection this set that we have here. So which elements of this set, since here we only have 3 elements, which of these elements also belong to A? So 2 is not in A, 8 is not in A, 10 is not in A. So A intersection B minus C is an intersection. This was A1. And if that day you are like, sets come like this, that day you must enjoy. Because the sets that gives us headache are sets like intervals -1 to infinity, or 10 to 3, 3 to 1. Those you think throughout, you have to do the lines, number line, but these are listed numbers. There's no headache here. Do we have questions coming from this? No question. Okay. Part 2. State the Morgan's laws and verify these laws using set A, using set B and set C. State Morgan's law and verify using set B and C. So, Morgan's laws, how many are they? There are 2. The first one is A intersection B. So now we're told we should state it in the terms of A and B and C, right? So let's use B and C even to state B intersection C complement is equal to B complement union C complement. 1. Law number 2 is B union C complement is equal to B complement intersection C complement. That's it, Morgan's law for the sets B and C. Now, we must verify using the sets B and C. So let's verify the first one. I'll do it from here. B intersection. So we're doing it to the left-hand side. B intersection C complement. So we first want to get, let's just get B intersection C. What is common in B and in C? This is different from what we were doing here. We are doing B minus C, so we are removing what was common. Now we want what is common. So what is in both sets? Those are clicked. They were found in both sets. So in the intersection, we have 3, 4, 6. Now what is the complement? The complement now is these elements from the inverse of them must remove whatever remains is in the complement. So in the inverse of remain, which is 0, 1, 2, 5, 7, 8, 9, 10. That's the left hand side. Let's see the right hand side. The right hand side. The right hand side. In the red. So now we want to B complement union C complement. Let's get B complement. All the elements that are not in B. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is in B. Union C complement. That's 1. Here even 0. That in B even 0. So in C complement again we have 0, 1, 2, 8, 9, 10. So what elements do we have? The union is everything that we're able to see here. We have 0, 1, 2, 5, 7, 8, 9, 10. And as we can see, the left hand side is equal to the right hand side. Fine. Have we seen?
Clear, sir.
Good. The question.
Yes, sir. I wanted to ask, so if in the sentence they use the word and, meaning they're talking about intersection.
Yes.
Thank you.
And when they say verify, they have not said prove. They have said verify. So show using the given sets. The issue of proving, you don't use examples. You prove in the general case. Let X be in this set and 2X move to other set. And so it's just verify. So you just verify. Okay. So I will leave this one for you to practice. You group B union C, get the complement on the left hand side. Is it the same thing as the other side? So on Saturday there was a quiz, and the issue of verification came, but now it was about using Venn diagram. So you think of it, what if they ask me to show this using Venn diagram? Do I know how to do Venn diagram? I mean, if this question came on the first part and they're asking us to use Venn diagram, then you draw the Venn diagram. This is B, C. So you put B, you put C. And you want to get the intersection C complement. So you shade here on this side. And then the other way, the other side again, because if they are the universal, so you also go outside. This is the left hand side. You also bring the right hand side and shade. Again, you shade the same piece of like that. And then you don't put an equal sign here. If you put an equal sign here, it becomes wrong. So you don't put the equal sign there. You conclude down, say the left hand side is equal to right hand side. Fine. Because if you put like this, then you can be like you're not doing anything, you just copy the same set. So you want to show that you did everything in your head, and that's what you came up with as the final thing. That's why I don't put that equal sign there. Okay. Then draw a Venn diagram to illustrate sets A, B, and C. So another question. Nice one. So if you want to do a screenshot, you do a screenshot now because I want to clear the box out. Maybe I can do this question somewhere. We want to answer part 3. Using the Venn diagram, are we able to illustrate the information given there? This is A, B, C. So let's illustrate. So for you to draw the Venn diagram to answer those sets, you first get the intersection of all the 3 sets. So we need A intersection B intersection C. So I can see 3, 3, 3. So 3 is here. What else? 5 is not in B. 7 is not in B. 9 is not in B. So only 3 will sit in between them. Let me put 3 here. Like that. And then we now go to A intersection B. A intersection B. Of course, 3 is there. 5 is not there. 7 is not there. 9 is not there. 1 is not there. So A and B, they are done intersecting. What about A and C? We have 5 in both. And then we have 7 in both. That's all. So we just have 5 and 7 there. Let's see B and C. So B and C, so 3 is gone, 5 is gone, for A, 3 is gone, 5 is gone for A, okay? Let's see B intersection C. We have 4. So we put 4 here. Do we have anything else? We have 6. No, there's no, yeah, there's 6 there. So 6 is gone. So C is just remaining with 7. That hasn't been listed by any set. Let's see. C, we listed 7 in the intersection. Yeah. So C is done. What about B? 2, 8, 10. We are not talking about. Yes. What about A? 1 and 9. 1 and 9. What about the inverse? I haven't seen 0. I've seen 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So only 0 will be sitting outside. So we have done the illustration of this whole set on the number. So you do it in steps. You start by listing the intersection for all the 3, and then the pairwise intersection, and then whatever elements remain in the set, like that. So now we can do the screenshot because one erase this and use the space to do B. Questions like this one. If you decide to use the mark, then it will be very unfair to you. Okay. Then let's talk about B now. Q1B 1. Prove that 3 plus root 2 is irrational. This question, even if no one tells you, you assume that 2 is irrational. In your proving. Then you say, let 3 plus root 2 be equal to A over B, where A, B are integers, B is not allowed to be 0, and A, B are co-prime. You do that. Co-prime means they do not have any common factor. After that, you have to write that thing as a first thing. When you are done writing that, make root 2 the subject. So just say root 2 is equal to A over B minus 3 over 1. And then B down, then A minus 3. Then say, but the left hand side is irrational. Right hand side is rational, which is contradiction. Hence, 3 plus root 2 is irrational. Stop. Any questions? Because this, you just pick it like this. There are only 3 things you're doing. The first thing is you write the condition statement. But let this be A over B where A and B are integers, B is not 0, and A and B are co-prime. That's the first thing, right? Second, you make root to the subject of the formula. After that, you conclude. You say, oh, but the left-hand side is irrational. The right-hand side is rational. So the two cannot be equal. If the two
So
can be equal, yes,
I have a question.
please ask.
What if it's just root 2 and then they tell you to prove that it's irrational?
Yeah, there will be more work as compared to this. That one will do it on, I think, on Facebook. Yeah, okay. So I can try to practice instead of if it comes, but it's not likely to be asked like that. This is the quiz standard of that. But you don't know. Wake up, then wake up. That's one thing to find sure that but expect it in this form. I consider they had it in this form. Had it in this form. Right, they mentioned that it's rational. Okay. Express the number. Express this number in the form A over B. So you let maybe x be the number given 0.32 back. As you can see, this 3 or 5 is fine. So as you can see that only 5 is under the bar. 3 and 2 are not under the bar. So the first thing we do is to multiply by 100. You multiply by 100 so that you move those two numbers. So you have 100x is equal to 32.5 bar. And then now you forget about this equation. You forget about it. Yeah. I've cancelled it. Not that it should cancel, but I'm telling you like forget about it. Then now multiply by 10. Multiply by 10. So you have 1000x is equal to 325.55. So we have moved the number under the bar a step to the left to the decimal point. Okay, now we can subtract. So now it will be 1000x minus 100x. This one minus this one is equal to 325.5 bar minus 32.5 bar. So when subtracting on the left, 100 minus 100, you get 900x, which is equal to 5 bar minus 5 bar, that's 0. 5 minus 2, you get 3. 32 minus 3, you get 29. Then you divide by 900 by 900. So you get x is equal to 293 over 900. Like that.
So
Hello?
do you simplify it more from like the way it is right now?
If it is simplified, yes. Do you think we have any number that can go in 293 and 900? I can't see that. Nothing. I can't see that.
Boa, Pamona.
If there was any, we could have 5. Yeah, there is. Okay, that's what we do there. We did it like that. If it doesn't have a bar, it becomes the easiest question. There's no bar, and it's just like 0.325. You know what? You just say, okay, whatever. 1, 2, where there's a decimal, put 1, then all other numbers, you put 0, 0, 0. Then you forget about this. So you have 3, 2, 5, of 1,000. 1.75. That's how you change it to a number. So you only get what when there's a back. So we've done question 1 fully. So that since the minutes remaining, we only have 3. So the out and then rejoin so as we finish. We only have 2 questions remaining, 2 and 3. So we'll look out quickly and rejoin.